Welcome everyone to Kellenberg Coding January Log. I hope you enjoyed your December break. The first thing I want to do is go over last month's assignment. Number 1, what are the 2 ways to write comments into your codes? One way is the double backslash. This is a 1 line of comment. And then there's the backslash asterisk, which is for multiple lines of comment. And then to finish the multiple lines, it's asterisk backslash. Number 2, how is the #include statement used? What would you write as the file name when coding for your Vex robot? This file contains predefined input-output functions that we can use in our program. In Vex code, you use include $vex.h. What is a namespace and what is it used for? What namespace would you use for V5 Pro? A namespace tells the compiler to look into that particular region for all of the variables, functions, etc. In Vex code, you use the Vex namespace. And I also wanted to point out that if your answers are somewhat along the lines of these ones, you're getting all the answers absolutely correct. If you don't understand it 100%, you can always either comment down below or you can ask in the Discord. Number 4, name the object in the STD namespace that will allow you to display content between the double quotes. The names and characters following are required. So this is cout with 2 carets pointing left, with quotation marks and your statement, and then 2 carets pointing right. Cout stands for character out, and it shows an output of only string characters. If you want an integer, the integer does not need quotations, and you just put the integer variable in between the 2 carets. If you declare a variable inside the main function, can you use that variable in another function outside the main function? What will happen? No, because you will get a compilation error. What is a global variable, and are they accessible anywhere throughout the program? Give a 2-line example of a character type global variable relative to int main. Hint: in order for characters to be understood, they need to be surrounded by single quotes. A global variable is a variable declared outside of any function and is accessible anywhere throughout the program. Example 1, integer number 1 is equal to 20, and then int main. So this means that if you ask what is int number 1 anywhere in your code, 20 will be the answer. As a character, example 2, character constant equals c, int main. Anytime you ask for the character constant anywhere in your code, c will be the answer. Where's the local variable limited to? Give a 2-line example of a character type local variable relative to integer main. Hint: in order for characters to be understood, they need to be surrounded by single quotes. A, the local variable is limited to whatever brace they are inside of, and example 1, integer main, int number 1 is equal to 20, so only in that int main function will int number 1 be equal to 20. If you have int main 2, and you define int main number 1 to be 40, then it will give the answer to be 40 only in int main 2. Example number 2 for characters, int main is character constant equals c. And number 9 is the final question. So I asked you to open the C++ shell and copy the following function. Include iOS stream using namespace std. Int main is going to hold the 2 local variables of int number 1 equals 60 and int number 2 equals 80. So as you can see here, when you type in the function I added afterwards, you need an if statement. So if num1 equals num2, so if you're trying to compare 2 numbers, you need the double equal sign. You need the squiggly bracket response to your statement underneath the if statement. So cout, the 2 caret brackets pointing left, num1 and num2 are equal. Here I put 2 caret brackets facing left because end L semicolons means that I want to start a new line, else cout num1 and num2 are not equal. And finally, cout num1 times num2 separated by the 2 carets. Now you're giving yourself a function to be solved, num1 times num2 in parentheses, what the computer is going to actually do the math with, and then end line, and return 0 to end your code. And as an execution, you get num1 and num2 are not equal, and num1 times num2 is 4800. So that was coding assignment number 1. You have another coding assignment for this month's homework. It's coding assignment number 2. There are 7 questions. And before we go on to Vex Code V5, we're going to be looking over while statements. And inside while statements, you can have if statements. So I decided to give an example here on C++ shell, just for you guys to get a preview of tonight's assignment. So I'm using IOStream here with namespace std. And in int main, I have a while statement true. You can have while statement true or false, it's a Boolean code, and I set integer to be grade. I'm applying an input statement here inside my while statement, grade is going to look for a number, not a string, which is letters or characters. As an character output, I'm going to ask the user, what grade are you in? You can't be in negative grades, so in the first count, what grade are you in? If grade is greater than 0, it's going to say you're a blank grader in robotics because you can only be either 1 through 12. And then we're going to break from the while statement, as you can see, because you do not want it to keep looping after you already answered the question. However, in the else statement, if you didn't answer the question correctly and put a negative integer, it's going to say, please choose an integer and repeat back to what grade are you in. That is just one example of a while statement. If you'd like to try one out for yourself, feel free. Here I show a time-lapse of me doing the same while loop example on an iPhone app called Code Playground, which you can find on the App Store. I wanted to mention it because if you do not have access to a computer, you can still either go to C++ shell on your phone or use this app. The output is also stated here. Now we're going to be moving on to Xcode Pro v5. So in the previous log, I showed you guys the very basics to just setting up your motors to a controller and a drivetrain. In this video, I'm going to be going over autonomous code and user control period code. When you set your drivetrain up with the 4 motors, that's called a smart drivetrain. So in the robot config, it sets it up for you. So if you are in a rush or if you want just the default, definitely do this, and then you can work further into it. As you can see here, let's look at while true, because this is the function control. So if you look here, integer driver train left side speed, it already sets the controller and axis. If you were to look at the axis in here, the left controller axis is 3, and the right controller axis is 2. As stated on the controller here and here, and it already tells the code to define it by position. And actually, I'm going to show you how to do it manually later in this video if you have motors that aren't going to be attached to the smart drivetrain. So, assuming that you do the smart way, but you don't want it to be 100%, we're going to have the drive velocity set to a certain percent, and you can find that in the command reference under drivetrain. You can look for drivetrain.setVelocity. You can copy this and paste it here. And we don't want it to be maybe 50%, let's say 75%, because I'm going to show a picture on the screen here. This is the robot I've been working on with the builders in my January log. And those are Omni wheels angled at 45 degrees to each other, which means they move in all directions, but maybe it would be too fast with a 200 RPM motor. So I want the drive velocity to be 75% instead of 100%. The set stop is going to be also defined, but let's define it before set drive velocity. And there are 3 types. There's brake, hold, and coast. Now, while doing research for this video, I tried to look up what the 3 definitions were because Vex Code did not give it to me. They just told me that it's a type of braking. They're just using the word in its definition, so that's not really that helpful. And I did Google what coast was, and coast as a verb means move easily without using power. So I'm assuming if you're going to coast your braking system, it's going to use the least amount of energy. If you brake the system, it's going to use more of a friction type of energy, and hold is going to remember what place the motor stopped, so when you start again, it's going to start from that rotation. So going back into our code, I'm going to say for this project, because it is Omni wheels, I want to save as much energy as I can, so I'm going to set my drivetrain to coast, set stopping to coast. So you got that down, that's the basics. If you have other motors, such as tray motors, clawbot motors, anything that lifts or is not part of the drivetrain, you also want to set percentages here if you're not happy, because the default is 100%. Now let's move into autonomous void. This is where you basically code for autonomous periods, and it's very important to do something at least here, because even moving in autonomous period and getting 1 point versus everyone else who doesn't have an autonomous period, that gives you the extra advantage and possibly extra points if you manage to get your autonomous code right. I remember in last year's competition, all we had to do was put the cube that was in our robot over into our goal, and as long as we scored 1 point, we won the autonomous round every single time. So I'm going to kind of base the same idea in my example, but I definitely recommend that you know the dimensions of your robot before you start the autonomous. So we're going to set the drivetrain again to stop. We're going to also set the drivetrain drive velocity to 75%. And you can see here it gives a helpful hint that I have 2 parentheses there. And it says here that it's red, so I forgot my semicolon. Now, to finish a word, so let's say drivetrain, it shows up. Click tab if you want to auto-complete it. Now we want to set our turn velocity. Down here, you can just click on it. And we're going to set that to 100% because maybe there's a little bit of friction, right? And if there's no friction, then you can always lower this percent. So that's the 3 to give the robot an idea as to how it's supposed to reference its driving abilities in autonomous period. However, if you just have these 3, the robot's not going to move. Now you want to actually move your drivetrain. So drivetrain.drive forward is going to be an infinite driving forward until something else stops it, such as the autonomous period is over. But we want it to actually move a certain amount. So we're going to do drivetrain.drive for, and we're going to do forward. And if I remember correctly, I had to drive forward 8 inches to the right. So we're going to do 8 inches. But I said to the right, so how are you going to drive forward and to the right? First of all, you have to drivetrain, turn right. If you think about it physically, if the robot turns to the right, then it needs some space to move forward or backwards. So if it's hugged against the wall, it can't turn right without possibly scratching the wall. So let's actually set our drivetrain forward 1 inch, and we can then subtract the 1 from here and make it 7. And then what we want to do is we want to drivetrain dot stop. And that's going to stop the robot from moving, and we set the stop to coast, so it already knows how to stop. And then I don't have any other motors here, but if I had other motors, I would start them, drop the cube, and then the autonomous period would be over. And if no one else had an autonomous period, you'd win. So that's basically the general idea of how autonomous works, and that's how the general idea of how user control works. If you didn't use a drivetrain, I want to show you how to do it if you just deleted this drivetrain and you just had 4 motors for your wheels. Alright, so now you can see here that drivetrain doesn't exist anymore because you deleted the drivetrain, so now it doesn't recognize it. So we're going to change the user controls period now, and we're actually going to change this to front left motor. You have to do it for every single one of these now. So you're going to copy and paste, and then the same thing for this. You're going to have front left motor. And not only that, but now you have to code for the controller axes to be red. So what you want to do is take the motor, set velocity needs to be red as controller1 dot axis 3 dot position, and then comma %, the same for the right, controller1 dot axis 2 dot position. The controller is now able to understand what it's using to control those motors. So now we have to go up back to our autonomous period, name all of these to the correct motor types. So now we're going to actually talk to the 4 motors individually to drive forward, and this time it doesn't recognize drive for, so let's go into the question mark. So instead of drive for, it's going to say spin for, which makes sense because a motor spins. So it's not inches anymore, it's going to be another unit. It's going to spin 1 time, so 360 degrees, and we're going to do that for all 4. Now, in order for something to turn right, it's not the drivetrain that turns right, it is the motors themselves. So in order to turn right, let's think of it in our heads. The right motors should stop, and the left motors should be at 100%, so that means copy and paste these last 4 lines and change them to 0 for the 2 right ones, and then we want it to go forward 7 inches, so we're going to again copy and paste the last things, and I'm going to actually use a calculator to see what 360 times 7 is. It's 2520, and now you want all of your motors to stop. So that is basically how you code for a drivetrain versus how you code for just individual motors. So tonight's homework, besides the assignment number 2 for C++ shell, I just want you to code according to a robot that you reference. It can be one of your friends, just include a picture and then tell me what you're referencing it to. Or it can be an online robot, and then you just take the picture and reference that as well. Maybe write some comments into the side. Remember, it's the double backslash, and you can just be like, since this is an omni wheel with less friction, the motors do not need to spin at 100%. A perfect explanation as to why you set your velocity to 75%. And I'll see that and I'll be like, he understands or she understands the physics behind what a robot can do, depending on what type of wheel, what type of motor it has. Other than that, I hope you all enjoy the rest of your month, and if you have any questions, leave them down in the comments below. Thank you all so much for watching, and I'll see you all in the next video. Peace!